Hi, I'm Gujjati Swati from VNR Vignana Jyoti Institute of Engineering and Technology. We, as a group of four members, did the project based on power system. Our main criteria is classification of faults. Our project title is Power System Faults Classification Using Machine Learning Techniques. We know electrical power system consists of different dynamic and interacting elements which are prone to disturbance or an electrical fault. The faults on the transmission lines are supposed to be first detected and then be classified correctly, and they should be cleared in least fast as possible time. The various different faults are simulated with different parameters to check the versatility of this method, and the proposed method is based on distribution network of power system. The various simulations and analysis of the signals are done in MATLAB environment.
Electrical power system consists of three parts, namely generation from thermal or nuclear or any other power plant, transmission and distribution using grids and substations, and finally utilization of power for residential or industrial purposes. Now, since these plants are located several kilometers away from the consumers, there are chances of faults happening anywhere in the system. There are two types of faults that occurs in the power lines, series faults and shunt faults. We are concentrating our work towards detecting shunt type of faults. Shunt faults can be line to line faults, double line to ground faults, or three phase fault. Generally, these faults are handled by microcontroller-based relays and circuit breakers. To make our analysis faster, we want to make our computers as intelligent as technicians sitting in a substation who can just by visualizing the voltages and currents can say the type of fault existing in the system for which we are making use of machine learning. These are the basic steps needed to complete a machine learning model. First, the data collection to analyze the model, then analyzing the data to pick an accurate model required for the application, then selecting the features we require for prediction, then finally implementing our application. The way we used machine learning to analyze the faults in power system will be explained by my friends.
This is a simple power system we designed to train our model and test it. Consists of a 22 kilovolt generating station and a power transformer to step it down to 11 kilovolt, and it feed into industrial which requires 11 kilovolts, and then it transmitted to other load areas like this. Now this 11 kilovolt is again step down for local distribution. This local distribution consists of three load areas: load area 1, load area 2, and load area 3. So let's consider the fault will be occurring at load area 1. This is so initially there is no fault between any of the phases. So when we try to simulate it and watch the voltages, as we would expect, all the voltages are sinusoidal. Yes, fine. So let's consider if there is a fault between any of the two phases. So if we simulate it, yes, the two phases are equal and dropped while the other phase is as it is. Okay. If we consider line to ground fault, let's say phase B to ground fault. If we try to simulate it, yeah, the phase B is completely grounded while the other remain unchanged. So like this we recorded multiple cases for our train data.
Now let us see the code that we wrote to predict the type of fault that the power system is going to have. And this is all the data that we collected from the Simulink model. If we change these parameters, either phase A, B, C or ground, then we are going to get the fault that is occurred in power system. Here I gave LG fault, and let us see what type of result it is going to give. So the answer is system is having LG fault. And similarly, if I give LL fault between A to C, and run this model, and I can predict the type of fault that is going to have. So the system is having LL fault. Similarly, I can change these to no parameters. The system that has no parameters is a healthy system.
Throughout our project, we have seen the classification of line to ground fault, double line fault. We can also use this analysis for three phase fault as well as double line to ground faults, where we have to provide more data sets. That's it. And the future scope of our project is that, along with the fault classification, we can use it for SAC calculations too. And by providing power electronic devices, we can use it for harmonic analysis also. Thank you for giving us the wonderful and golden opportunity to expose our project. Thank you once again.